All right, so today we're going to talk about annuities. So, annuities is a series of equal payments made at regular intervals, usually paid at the end of each compounding period. So, things like mortgages, where you're paying monthly for those things. If you're doing investments, you're putting in money regularly into something. Um, like RRSPs, if you're saving for retirement, you can have savings plans kind of set up so that the same amount goes in, or our ESPs, which is like a registered education savings plan. So your parents might have an RESP for you, where they've been saving up money for your post-secondary education. Do they? Do you know?
I would assume.
Yeah, that, or you're gonna have some student loans. Um, and we can calculate how much. So if you make a certain percentage on those things, let's say you're investing and you make a certain percentage back, then you can figure out how much with a regular contribution plus the interest your annuity will be worth in the end. Okay, and then similarly, if you're like paying something off, you can figure out how much of that is paid interest. So obviously, the bank is not going to give you a mortgage for not getting any money back. You have to pay back what your mortgage is, but also any extra interest. And interest rates will change depending on what type of mortgage you select, but you could figure out how much you paid in total for that. Okay, so here's the formula. I want you to recognize, we might see the formula kind of shown where R over CP is actually equal to I. So what we do is we do the interest rate as a decimal divided by the number of compounds per year, and that will give us I. So technically these two things in this formula here can be represented by I. So if you happen to see that formula, you just know that it's rate divided by compounds. So if I make, just for an easy example, if I make 12% per year, but we compound monthly, I'm making 1% each of those months, not 12% every single one of those months. So you take that 12% and you divide it by 12 equal compounds to divide that into a total of 12. And then CP times T is often represented by N. So it's essentially the total number of compounds within the total time. So if there's 12 compounds per year and you're investing for, let's say, 6 years, you would have compounded your interest 72 times over that whole time, right? 12 for 6 years. So you might see this listed as I, and you might see this shown as N within that formula. Okay. A is going to represent the final amount. So either like the final amount that has been invested plus the interest, or the final repaid amount if you're repaying a loan or something like that. Okay, and that's in dollars. And then R is going to be the regular payment amount. So if you're putting in $300 every month for an investment, that's called the regular payment. Okay, and that's also in dollars. All right, so one important thing to note is that this formula is for if your payment intervals match the compounding period. So if I were to invest something monthly, it would have to be also compounded monthly. And the payment will be made at the end of like each of those compounding periods. So you'd have to be like regularly investing something every single month of the year, and your interest would also have to be being added on every single month of the year. Otherwise, the formula does not work. So for all of our examples that we're going to do, you're going to always see that the person investing is going to match the compounding periods, like how often they're investing or how often they're paying something off. All right, so just remembering for like number of compounding times what your CP value will be if you see things like daily, monthly, weekly, and all of those kinds of things. So daily is 365, monthly is 12 times a year, weekly would be 52. Bi-weekly is every other week, so that's 26 times a year. And I'm just going to make a note that's every other week. Semi-annually is 2 times a year. Okay, one at the 6-month mark, one at the 12-month mark, and then every 3 months. In other words, quarterly. That gives us 4 compounds per year. Okay, so let's do an example. We have $450 that's deposited at the end of each quarter for 1.5 years at 10% per year. So this is an investment. Compounded quarterly. So you see like at the end of each quarter and compounded quarterlies, those have to match in order for us to use this formula properly. What is the future amount of the annuity? Calculate the amount of interest the annuity earned. Okay, so we're going to use our annuity formula, and we're just going to write out the variables right now to start. All right, so do we know how much money we will have after that whole investing process happens? Okay, so that's our future value of our annuity. Do we know the regular amount that's being deposited? Perfect. Do we know compounds per year? Yep. Yep, 4 compounds per year. R is interest rate as a decimal. Yep, or 0.1 is fine. And then T is time in years. Perfect. Okay, so we're going to enter that all into our annuity formula above. All right, so we will pause here to do a calculation. If you're watching the video, you can pause the video and try it out. One helpful thing as well, depending on the calculator that you have, is maybe just calculating these bits before you enter them into your calculator. So you can do that if you want to do that. Gabe, I think your calculator is pretty straightforward as far as entering those things in, right? Okay, so you don't really need to do that, but maybe if somebody's watching the video, they might need to do that. And then plug it into their calculator from there. What'd you get, Gabe? 20,000? Let me double check here.
Okay, perfect. So maybe just one area of mistake is just to make sure that you have brackets around this entire piece on the top. So that 450 needs to be multiplied by both things. So in the end, we should get 2,874,000 Now this one also asks us to calculate the amount of interest that the annuity actually earned. We're not done yet. So we need to figure out, obviously, if this is the total amount of the annuity, that's interest plus what we put in ourselves. We're putting in $450 4 times a for 1.5 years. So we need to figure out how much of that is what we put in and how much of that is actually interest that's added on here. So the interest is going to be the total amount of the annuity minus all of the payments that alright, so this says if we are doing 1.5 years for 4 times a year, that gave us 6 times per year. So if I have done 6 payments of 150, my payments are going to be 450 times 6, of course, because I did 6 of them. And again, you can do that by multiplying the number of years by the number of compounds that you have there. So I'll just put T times C. And then, of course, we know that the total amount of our annuity is what we calculated. The difference between those things, how much I put in myself and how much the annuity is obviously the interest that was earned on Perfect. So $174.48. Okay, so therefore, remember we need a therefore sentence for everything. The annuity grew to 2,874.48 and $174.48 of that was interest. Okay, let's do another one. Alright, Tom and Beth are twins. They save for retirement as follows. Tom, starting at age 25, he deposits deposit $1,000 at the end of each year for 40 years. Beth starts at age 45. She deposits $2,000 at the end of each year for 20 years. So Tom is investing for double the amount of time, obviously 40 years versus his twin Beth. Both annuities earn them 8% per year compounded annually. Who will have the greater amount at retirement? What do you think? Okay, so we're gonna do some calculations here and find out. So let's start with Tom, and then we'll do Beth on the other side here. Alright, so we have A, R, CP, little r, and T. So what do we know out of these so far? So the regular payment, that's capital R, so 1,000 for Tom. You want to just fill it out for Beth at the same time, so we're ready? Okay, what is that for Beth? What is her regular payment amount? 2,000. Okay, what are the compounds per year? Yep, it's compounded annually. That means one time a year. So compounds are 1 for each of them. Our interest rate as a decimal. And that's the same for both of them. They're both getting the same interest rate. And T, time in years. Yeah, okay, perfect. And the amount of the annuity is unknown. Okay, so let's plug in for Tom here. We have the rate and then we have 1 plus r over the compounds. So because this is just over 1, we're just going to put in 0.08 for those ones. Save ourselves an extra line of work here. And then T times compounds per year, that'll be 1 times 40. So our exponent is just going to be 40 there. And then again, we have rate over compounds per year, so that's just 0.08 since we divide it by 1. Alright, so we're going to pause for a quick calculation here. You can add those together preemptively if you want, or you can just put it in your calculator as is. I will just add them together. Alright, so you should find that this one gives you out $256.52. Now let's calculate for Beth. So same setup. She's now entering 2,000. We're paying 2,000 per year. Same interest rate, different amount of years. So we have 1 compound per year for 20 years. So that's going to give us 20 compounds of the interest. And then 0.08 technically divided by 1 on the bottom there. Alright, so we'll pause for calculation if you're calculating. Okay, and you should get $91,523 and 93 cents with rounding here. Alright, so were you right? Did they end up with the same amount? Yeah, yeah. So what does this tell you? Why? Why did that happen? Well, he's putting half the amount of money in for double the time. So they're really paying the same amount, right? If he pays $1,000 for 40 years, that's $40,000. If Beth pays $2,000 for 20 years, that's also $40,000. So they both put that in. So why is he making so much more than her? Yeah, exactly. So that interest really makes a difference. Okay, so therefore, Tom will have a much greater amount. Uh, so the next part of what you're going to be doing is you're going to use a calculator to figure out me versus you in investments. So here's the setup, and you're gonna use your laptop. Ideally, is at church. Ready? Okay. So you can either Google calculator soup investment calculator, or you can just go right to this URL. I can post this lesson for you if you want to click it from there, but it's probably just quick just to do calculator soup investment calculator. And then we are going to see who makes more at retirement. We're both going to invest the same amount, but you're going to put $500 in your account initially, and I'm going to put 5,000, and we'll see how that compound interest weighs out.